is the magnitude of a point charge in coulombs whose electric field is 59 centimeters away and has a magnitude of 1.8 newtons per coulomb? That is the problem we will be solving today. So the first thing we should do is we should probably write this out as a visual representation. So we have Q1 over here, our particle of unknown charge. We have our force that was measured, and we have the distance between those two things. So we have a distance measurement, we have a force measurement, and we have a charge measurement that we're trying to find. So what equation has all three of those components and is the easiest equation for us to solve? I'll give you a second to think about it. All right, so our equation that we're going to be using is Coulomb's law. I know, it's easy, and it has every single part of it. Now, if you didn't get it, that's all right, because in Coulomb's law, there is always a second charged particle. Well, the fun thing about Coulomb's law is we can easily erase it because it does not apply to our equation. So now we have just made an even simpler equation for our problem. So everything we have is good. Okay, we have our force vector, so we have that. We know what Coulomb's law is. We're trying to solve for the magnitude of Q1, and we have a distance. However, the distance measurement, which is 59 centimeters, is not in the correct measurement. So what we have to do is take that 59 centimeters divided by 100, and that gets us 0.59 meters, which is what all measurements have to be for our set of equations that we use in physics. So first thing we're going to do before we have to plug these numbers in just to make everything easier is we're going to solve this equation using the variables, not plugging in the numbers. So the first thing we're going to do is we're going to cancel out the r squared beneath Q1, and we're going to move it over to f. Second thing we're going to do is divide by k so that we can get Q1 by itself and get ourselves this lovely equation. Now, when we plug everything that we know into it, we get this beast. Now, it's not as complicated as it thinks, so once you do the math for it, you should get something like this. You get the magnitude of Q1 is equal to 6.98 times 10 to the power of 11 coulombs. Now, this is an acceptable answer. There's nothing wrong with this, but you can also write your answer as this, because we do not know the charge of the particle. It can either be positive or negative, and that force will still be the same at that point. So, in conclusion, if you have a particle, a force measured a set distance away, you can very easily solve that problem using Coulomb's law that you only have to slightly modify, and you can get your force, or you can get your charge of that particle.